Hello, welcome to our second week of Neuroscience peer tutoring video series. My name is Jonathan. I'm going to be taking you through the brainstem functions today, especially focusing on the cranial nerves. So 3 things we're going to go through today. First, we're going to have a basic overview of the brainstem anatomy. Moving on, we're going to look at the cranial nerves, their names, location, and their function. And thirdly, we're going to plot them all in a graph so it's easy for you to visualize. So here's a basic structure of the brainstem, and I'm going to put in a couple of landmarks so we can visualize it. Now, I'm going to draw 2 lines in there where it's going to divide it up into the midbrain, pons, and medulla. And here is just an arbitrary midline right down in the center of the brainstem going down to the inferior portion, and you can see that the parts posterior to that line is what we call the tegmentum. So the tegmentum is the part between that line and the 4th ventricle behind it. And then anterior to that line I drew will be the basilar portions. It's important to have a look at what their functions are. So the basilar portions contains all of our important tracts coming from the cerebrum, whereas going down to the posterior part, the tegmentum, this is the part we're going to focus on today because that's where our cranial nerve nuclei are going to be located. Just a couple of landmarks to finish it off. There's the cerebellum right down the back, and then just above the cerebellum there is our superior and inferior colliculi for sensory integration. Together they're also called a tectum. I'm going to focus on the tegmentum now. First, I'm going to start by dividing it into the midbrain, pons, and medulla. As you can see, I'm going to draw a line right down in the center here. And you can see there's the medial portion and there's the lateral portion. Medial, M for M, so everything to the left on that diagram, so the medial part is going to house the motor nucleus, whereas everything to the right is going to house the sensory nucleus. Now, as you can recall, the motor there are actually several types of motor and sensory nucleus. In the motor part, we have the somatic, which controls the facial expression, the visceral, and also the branchial, which controls the muscle for chewing and swallowing. On the sensory side, there's also 3 types, where there's the visceral, somatic, and the special sensory nucleus. I'm going to plot them onto the graph now. Now, visceral nuclei are right next to each other, so visceral and visceral are going to be right in the center. I'm going to plot in the motor nucleus now, and then the sensory nucleus. And here is our 6 columns of our brainstem, including dividing into portions, so midbrain, pons, medulla. So moving on to this table that I have drawn before, we look at the different kind of nerves. So this table consists of nerve, their location, the type, subtype, their functions, and the lesion. And moving down the table is just the 12 cranial nerves. I'm going to first plot in the location. Now, optic nerve and olfactory nerve, the cranial nerve 1 and 2, are actually located in the brain, not found in the brainstem. So we're just gonna skip that. And moving on into our midbrain, our oculomotor nerve and trochlear nerve are found in the midbrain. Into the pons, we have trigeminal, abducent, facial, and vestibular cochlea. And lastly, in the medulla, there's the glossopharyngeal, vagus, and the hypoglossal. Important to note that the spinal portion actually houses the accessory nerve, so that it doesn't actually come from the medulla. It arises from the spinal portion and comes back up into our brainstem and give rise to those nerves. We're going to look at types now. So there are 3 types of nerves that we should know about. So there's the sensory nerves, there's the pure motor nerves, and then there is the mixed nerves, where we will spend the most time on. Starting with the pure sensory nerves, we have the olfactory, optic, and vestibular cochlea. They are all our special sensory nerves. Olfactory nerve is important for our smell, whereas the optic nerve is important for our vision. And if there is a lesion in there, we're going to get a loss of smell, which is anosmia, and anopia, which is a defect in the visual field if we have a defect in the optic nerve. Moving down into our vestibular cochlear nerve. It is also a special sensory nerve, and it is important for our hearing and balance. Hearing portion being the cochlea, and the balanced part being the vestibular. And any defect is going to give us deafness with or without dizziness and imbalance. Plotting them onto the graph now, as you can see, we don't have the first and second nerve on the graph because they're in the brain region, and really we're just going to look at the vestibular cochlea, and there are two nuclei, one's the cochlea and one's the vestibular, and that's as plotted. Moving on to the motor component now, we're going to look at our third nerve, oculomotor nerve. Again, a pure motor nerve, but it's got two components. There's the somatic component and there's the visceral component. The somatic component controls 5 muscles in total. There's the 4 muscles that controls the ocular movement, and there's one that controls the eyelid. There's the superior, inferior, and medial rectus muscle, plus the inferior oblique muscle. And the muscle that controls the eyelid movement is called the levator palpebrae superioris. The visceral component, which is the Edinger-Westphal nucleus, it controls the parasympathetic function for the eyes. What happens if there is a lesion in that nucleus? We're going to lose all 4 of our oculomotor muscles, so we're going to have a lateral rectus overcompensation, so our eye is going to be looking out. There's going to be a superior oblique muscle overcompensation, and that causes eyes to look down, and then we'll get that ptosis because of our defect in our levator muscle. So overall our eye is going to look down and out, plus a little bit of drooping. We're going to get parasympathetic dysfunction from disrupting the Edinger-Westphal nucleus, and that leads to the dilation of the eye, which is also called mydriasis. Moving on, there's the trochlear nuclei, which is next. It is again a somatic motor nucleus that controls the superior oblique muscle. And when that goes wrong, we are unable to look down, and this is exaggerated when we're looking medially in the affected eye. The abducent nerve, the 6th nerve, controls the lateral rectus, and a defect in that will lead to an inability to look laterally. Now moving on to our last 2 nerves, we're going to start with the hypoglossal nerve. Again, a somatic motor. It controls the tongue muscles except for the palatal-glossus. And there's the accessory nerve, which controls the trapezius and the sternocleidomastoid muscles. So when the hypoglossal nerve has a lesion in it, we get a tongue wasting. And when there's a lesion in an accessory nerve, we get shoulder muscle wasting. Now, plotting them in the graph, all of the nuclei that I just talked about are somatic. So I'm just going to plot them in a line and label them. And never forget that visceral motor Edinger-Westphal nucleus, which is part of the third nerve nuclei. Moving on into our trigeminal nerve now, it is the first mixed nerve that we're going to look at. Being mixed is going to have both a sensory function and motor function. And specifically for the trigeminal nerve, there's the somatic sensory and there's the branchial motor. Somatic sensory divides up into 3 separate nuclei. There's the mesencephalic, chief, and spinal nuclei. Now, all 3 nuclei actually all converge into the trigeminal nuclei somewhere above, and it will divide up into 3 separate branches, our V1, V2, and V3. V1 being the ophthalmic branch, and then down to the maxillary and down to the mandibular branch, which gives the sensory supply to 3 different parts of the face. Coming down to our motor portion, the branchial motor portion, it controls the muscles for mastication, and it also controls 2 little muscles, one our tensor tympani and 2 our tensor villi palantini. The major defect of having a trigeminal lesion is either numbness or severe pain of the face. Now, plotting our trigeminal nuclei onto our diagram, in the somatic sensory column, I'm going to draw 3 nuclei. It's the mesencephalic, the chief, and the spinal nuclei. And really, you can just consider them as one continuous nucleus that's running down the somatic column in the lateral portion of the brainstem. And moving on, there's also that motor nuclei of the trigeminal nerve located in the branchial portion that controls the couple of muscles that I previously mentioned. Now, going on to our second mixed nerve, the facial nerve. Again, there's the motor portion and the sensory portion. Starting with the motor, there's the branchial and there's the visceral part. The branchial part controls the muscles for facial expression, whereas the visceral part, which is housed in the superior salivatory nucleus, and it controls our autonomic function for salivation. The sensory function of the facial nerve is housed in the solitary nucleus, which is in the visceral column, and it controls the taste and sensation for the anterior 2/3 of the tongue. Now, if there's a defect on the facial nerve, we'll get a facial droop, and that is the predominant symptom of getting a facial nerve defect. Plotting them onto the graph now. There are three nuclei that I'm going to draw on. There's the facial nucleus in the branchial portion, the superior salivatory nucleus in the visceral portion of the motor part, and then there is the solitary nucleus in the visceral part of the sensory column. Now, important to know that the solitary nucleus is actually divided up into three different portions, and three nerves contribute to it: our facial nerve, our glossopharyngeal nerve, and the vagus nerve. That moves on nicely into our ninth nerve, the glossopharyngeal nerve. Again, motor and sensory component. I'm going to start with the sensory component now because that's a continuation of our solitary nucleus from our facial nerve, and that's going to control the taste and sensation for the posterior 1/3 of the tongue. The motor part is divided into branchial portion and visceral portion. The branchial portion is housed in the nucleus ambiguus, whereas the visceral part is housed in the inferior salivatory gland, right underneath the superior salivatory nucleus of the facial nerve. Now, what do they control? The branchial portion controls some muscle for swallowing, and the visceral portion again controls the autonomic function, which is the salivation. If there is a defect in the glossopharyngeal nerve, we're going to get an impaired swallowing, impaired saliva production, and then you're going to lose the posterior 1/3 of the tongue in terms of taste and sensation. Plotting onto the graph now, I'm going to put three nuclei down. The first one is our nucleus ambiguus, the second one, the inferior salivatory nucleus, and the third part, I'm just going to plot my ninth nerve onto the solitary nucleus, which I have previously drawn. Alright, bear with me, we got one last nerve to go, and that's our vagus nerve. Divided into the motor and sensory component, I'm going to start with the motor part, which divides into the visceral component, housed in the dorsal nucleus of the vagus, and there's the branchial component as well. The visceral component is going to control the parasympathetic function around our body, including the gut and several other organs, including the heart. The branchial motor portion of the vagus is also going to be housed in the nucleus ambiguus, and it helps with the swallowing function. Moving down into the sensory component now, there is that visceral function that's housed in the solitary nucleus, along with the facial and glossopharyngeal nerve, and it's there for the purpose of sensation of the pharynx. What happens when the vagus nerve goes wrong? There are a couple of symptoms that might occur, including hoarseness, the loss of gag reflex, and also poor swallowing. And lastly, plotting the vagus nerve onto our graph now. The only new one that I'm going to draw here is the dorsal nucleus of the vagus nerve, and then the vagus nerve is just going to occupy the inferior portion of the nucleus ambiguus and also the inferior portion of our solitary nucleus. That completes our diagram, and that concludes our cranial nerve tutorial. We hope you enjoy it and stick around for our tutorial in the following week.